Welcome to AI ConvoCast, where we bring you the latest in AI and tech innovation. Quick housekeeping. Check out the affiliate links in our description. Using them supports the show, and please don't forget to rate, review, and share if you like what you hear. Let's jump right in. Today we will be discussing OpenAI's decision to permanently remove Mixpanel from its systems following a data exposure incident, Microsoft's launch of Fara 7B, a new on-device model designed for computer control tasks, and UC Berkeley's chain of visual thought framework that lets models reason using visual information directly. OpenAI has cut ties with analytics provider Mixpanel after discovering unauthorized access to user data. The incident involved an export of limited user information from Mixpanel systems, specifically names and email addresses that were accessible through an API interface. OpenAI was quick to clarify that the exposure did not compromise any of its core systems or sensitive content, and critically, no passwords or API keys were affected. The breach was confined to the analytics layer, which handles user behavior data rather than the actual content or conversations users share with OpenAI's products. In response to the incident, OpenAI took decisive action. As an OpenAI spokesperson stated on November 29th, "We've removed Mixpanel entirely from our production systems. The company has launched a full investigation into how the unauthorized access occurred and is working to understand the scope of the exposure." OpenAI is also warning users to remain vigilant for potential social engineering attempts, as attackers could use the exposed email addresses and names to craft targeted phishing campaigns. This incident highlights the growing challenge of third-party supply chain risks in the technology space. Even when a company's core infrastructure remains secure, the services and tools they rely on can become vulnerabilities. Analytics platforms like Mixpanel sit at the intersection of user behavior and business intelligence, making them attractive targets for attackers looking for information that could be leveraged in future attacks. Microsoft Research has released Fara 7B, a 7 billion parameter model that represents a significant step forward in how AI agents interact with computers. Unlike traditional models that rely on cloud infrastructure and require constant internet connectivity, Fara 7B is designed to run entirely on device. The model works by taking screenshots of a computer interface and predicting the coordinates where actions should occur, effectively allowing it to control software just as a human would by clicking, typing, and navigating through applications. The real innovation here is the combination of capability and accessibility. Fara 7B is being released as an open-weight model, meaning researchers and developers can download it, study it, and integrate it into their own projects without needing permission or paying licensing fees. Despite its relatively modest size by today's standards, the model reportedly outperforms larger agents in the Web Voyager class, which are typically used for complex web navigation tasks. Microsoft achieved this through something called the Faragen synthetic data pipeline, which generates verified user interface task trajectories at scale. Essentially, the system creates realistic examples of how to accomplish tasks on computers, then verifies those examples before using them to train the model. Running locally offers two major advantages. First, latency drops dramatically because the model doesn't need to send data to a remote server and wait for a response. Second, privacy improves substantially since sensitive information never leaves the device. A Microsoft research engineer captured the vision succinctly on X, saying, "Local agents are the future, fast, private, and capable." The model is optimized to run on standard laptops, making it practical for everyday use rather than requiring specialized hardware. This democratization of agentic capabilities could accelerate the development of assistive tools that help users automate repetitive computer tasks, from filling out forms to managing files to controlling applications through natural language commands. Researchers at UC Berkeley have introduced Chain of Visual Thought, a framework that fundamentally changes how models process visual information. The approach addresses a long-standing limitation in how AI systems handle images. Traditionally, when a model encounters an image, it converts the visual information into text descriptions before reasoning about it. This conversion step creates what researchers call a language bottleneck, where subtle visual details, spatial relationships, and continuous properties get lost in translation. Chain of visual thought allows models to reason directly with continuous visual tokens, maintaining the richness of the original image throughout the thinking process. Instead of forcing everything through the narrow channel of language, the framework uses compact latent representations that bridge image understanding and language output. The model can think in visual terms, manipulating and reasoning about visual features in their native format, then express conclusions in natural language when needed. This approach shows particular promise for tasks that require pixel-level reasoning. In scientific domains, researchers often work with imagery that contains precise measurements, subtle gradations, or complex spatial arrangements that are difficult to capture in words. Medical imaging, satellite analysis, microscopy, and materials science all involve visual patterns that carry critical information. Robotic perception presents similar challenges, where a robot needs to understand three-dimensional space, object properties, and fine-grained details to manipulate objects successfully. As one UC Berkeley researcher explained, CoVT helps models think in vision-first terms, keeping the reasoning process aligned with the nature of the information being processed. The framework doesn't abandon language entirely, but rather positions it appropriately as an output format rather than an intermediate reasoning step. By eliminating the forced conversion to text in the middle of the thinking process, Chain of Visual Thought preserves information that would otherwise be discarded and enables more sophisticated visual reasoning. The implications extend beyond specific applications to touch on fundamental questions about how multimodal models should be architected, suggesting that different types of information may require different types of internal representations rather than forcing everything into a single modality. These developments reflect ongoing efforts to make AI systems more secure, more capable, and better suited to the tasks we ask them to perform. The OpenAI incident demonstrates the importance of carefully vetting third-party integrations and having response plans ready. Microsoft's Fara 7b shows how on-device processing can unlock new possibilities for privacy-conscious applications. And Chain of Visual Thought points toward architectures that respect the native structure of different types of information, potentially unlocking capabilities that have been constrained by forcing vision through language. Thank you for listening to AI ConvoCast. Please don't forget to rate, review, and share if you like what you hear. Thanks and hope to see you again next time.